Welcome to the Walton Pi. Today we're going to be talking about what it means for something to be a ring homomorphism. So to start off, let's let G and H be rings whose operations are addition and multiplication. And we're going to say that a map phi from G to H, remember this is a map between rings, is a ring homomorphism if for every x and y in our ring G, we have phi of x times y is phi of x times phi of y, and we also have phi of x plus y is equal to phi of x plus phi of y. And this has to be true for every pair x and y in G. Note that the operations are denoted the same, but they are addition and multiplication in the different rings. So for example, in our phi of x times y, that multiplication is multiplication in G. But then phi of x times phi of y, that is multiplication in H. The multiplications and additions might be defined differently in different rings, so you do have to check both of those to see does this actually work. Now we say that a map phi from G to H is a ring isomorphism if phi is also a bijection and is still a ring homomorphism. So isomorphisms are just bijective homomorphisms. That's true whether we are talking about groups, rings, fields, whatever. Isomorphisms are bijective homomorphisms. So let's go over an example. Let's define phi from z to z12, where z12 is the integers mod 12, by phi of n is equal to n mod 12. Both of these are going to be rings where we have the standard addition and standard multiplication, which are well defined in both cases. So to check that this is a ring homomorphism, we're going to need to check that phi of m plus n is phi of m plus phi of n, and that phi of m times n is phi of m times phi of n. So let's start off with phi of m plus n. Well, that is m plus n mod 12, which we can break up as m mod 12 plus n mod 12, which is phi of m plus phi of n. So we have the first condition. We have the group condition to show if this is a ring homomorphism. Now let's check the multiplication. Well, phi of m times n, that is m times n mod 12, and a nice property about multiplication in integers mod a number is it distributes. So that's the same thing as m mod 12 times n mod 12, which is phi of m times phi of n. So all of that means that phi is a ring homomorphism. However, it's not a ring isomorphism because this map is not bijective. It can't be. The integers have infinitely many elements, and z mod 12, that has 12 elements. They can't be isomorphic because they have different numbers of elements. So this is not a bijection, so this is not a ring isomorphism. I hope this helped understand what a ring homomorphism is and what a ring isomorphism is. If it did, please like and subscribe. It really helps me out. And if there's other topics you would like to see me make a video on, please leave that in the comment section down below. I hope you have a great rest of your day and good luck with all of your math.